Hello guys, how are you all doing? Can you all hear me that side?
Yes, sir.
Yes, sir.
Okay. All right. Thank you guys. Then let me now quickly. Oh, firstly, guys, I'm sorry for being late. My apologies. Let me quickly share my screen. And then I share my screen. And then I quickly go to the textbook. Okay. Can you all guys see my textbook that side?
Yes, sir.
Okay. Then without wasting another time again, let me just dive into these problems. So I would love us to first just remind ourselves with this proportionality theorem so that we can proceed to the topics that I want us to look at for today. So we are going to do this question number F. They are saying in the sketch alongside, PU is parallel to QT. Okay, we're given that PU is parallel to QT. Okay, we are done with this information. And then again, there's this one, PT is parallel to QS. So, okay, also we are given this information 5PQ as 2 times PR. Okay. Therefore, now when you are here, you can just divide by PR on both sides. You can divide by PR on both sides of PR. So that now this cancel out. We are left with this. And then now we can times by 1 over 5 on both sides. Okay. Then now we are left with this, and then I cancel this. I cancel this here again. Okay. I cancel this other 5 here. Therefore, now my PQ over PR is equal to 2 over 5. Then I take that information to the diagram that, okay, PQ is this one. PQ is 2. What is it? Is 2. Give it a variable. And then now PR is 5. So if that PR is 5A, therefore this will be 3A. 3A. Okay. Then now we can play around our proportionality theorem to move that ratio to this other side. Therefore, now on your paper, you will write this for me. Boom, 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 boom. And then now you will write this for me that PQ over QR, PQ over QR is equal to UT over TR. They are all equal to PQ, UT. They are both equal to 2 over TR and QR and TR. They give me 3. Therefore, now UT, which is this one here, it gives me 2. I give a variable B. Okay, and then now my TR is 3, and then I give a variable B as well. Okay, and then again in this triangle RPT, we still can see that the proportionality theorem applies there because of that parallel lines. PT is parallel to QS. Okay, therefore, okay, I forgot the reason for this one, guys. I'm sorry. Prop theorem. Then you state your parallel lines that PU is parallel to QT. Okay, And then now again that P Q over QR is equal to TS over SR. Okay, P, Q, and TS, they are equal to 2. QR and SR is 3. Therefore, now I will come to this part. TS is 2, but I give a variable C. Give it a variable C. And then now my SR here is 3. I will give it a variable C as well. Okay, now let's go to the question and see what is requiring us to find. US over SR. US is this one here. It's this part UT, okay, this portion plus TS, that is US. Okay, then I can come to this part. I say my US is 2B plus 2C all over, and then SR is this portion here. Therefore, now it gives me 3C. Okay, now since we have got different variables in this expression of mine here, we need to find the relationship between the two so that we can be left with only one variable. So now let's see how we can find the relationship between the two. Okay, we can see that here for this part, here, TR is equal to TR is equal to TR. The greener part of TR there is 3B, okay, is equal to the red one, gives me 5C. Therefore, you can divide by any on both sides. Therefore, now my P becomes 5 over 3C. Okay, this is my B. Now, wherever I see B here, I'm going to substitute 5 over 3C. Okay, now I'm going to have that 2 times this, which gives me 10 over 3C plus that 2C, we can write it as 6 over 3C. Okay, all over 3C. And then my numerator there gives me 16C all over 3. Then now everything all over 3C over 1. Then that gives me 16C all over 9C. Therefore, these C's cancel out. Now I'm left with 16 over 9. Then you are done. Does this make sense to everyone, guys?
Yes.
Okay, Tabile does understand. What about others, guys? Are you still following?
Understand, sir. Yes,
Okay.
I'm following.
Okay. Thank you, guys. So please just shout it out if you maybe did not understand something. Okay, we are done with this part, guys, of playing around with those ratios using proportionality theorem. Now let's go to some different part, whereby now we are required to calculate the areas, the area ratios, because it's area over area, and so on. They are saying in this section you will learn how to calculate the ratio of the areas of two triangles under specific conditions. So there are some conditions that you will work on, some perpendicular height, common angles, parallel lines. We will see as we go there. So now let's just for now talk about this type 1 here. So type 1 here, they are saying it's whereby there is the same perpendicular line. So now I've got a question for you guys here. Let's say I have got this triangle here, and it's a right angled triangle, this one here. And then we have got A, B, C. And then now the length of AB is H, okay, is 90 degrees this angle. And then BC, the length of BC is B. So any one of you guys who can tell us how we can find the area of this angle? Is there any one of you guys maybe who can tell us how to find the area of this triangle ABC?
Sorry, sir. Did you say triangle ABC?
Sorry?
Did you say triangle ABC?
Yes, this triangle that I've drawn here, the red one, ABC. I just want anyone who can tell us how to find the area of this triangle that I've drawn here.
Half base times height.
Oh, yes, yes, absolutely. Now, the area for that triangle will be half, and then the base of this triangle will be just that B times that height H. Thank you, sir. That is 100% correct. So now let me change this triangle of mine here. Let's say this triangle now is like this. Okay, let me erase this part here. Let me erase this part here. And then now my B is there. This is my B now here. And then we have this height here. And then now what is going to be the area of this triangle? Anyone guys who can give it a try?
Sir, can I try?
Yes, you can give it a try.
I don't remember it correctly, but it has to do with an example for, like, for example, you would have to say d squared equals to a squared plus b squared minus 2ab cos
Oh,
something around that. I
so
forgot how it is correctly.
you are saying b squared
Equals to
equals to
uh a squared
a squared plus c
plus c
squared
squared.
minus 2ab
No,
AB and
2ac.
then cos angle. You're talking about this.
Yes, sir.
Oh, okay, okay. Then this is a cosine rule. This is a cosine rule that you maybe can use in there in trigonometry to find maybe, or actually the cosine rule works like this. If you have this triangle ABC, and then you can give this length A, and then this one B, this length here C. Now maybe you are given the angle, this will be angle B here. You are given an angle here, maybe theta. Then they say this is equal to 4, and then this is equal to 6, and then you want this. Then this angle here is 30 degrees. Then now that's when you can use cosine rule. I don't know if this makes sense, sir.
It does, sir. It does. Sorry.
Are you sure?
Yes, sir.
Okay, thank you. So this is the cosine rule will work only on that situation that I've just explained here. Okay, and then let me just go back to what I was doing. Boom, 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 boom. Hey, my eraser is a bit lazy here. Da, 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 da. Da, 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 da. Ah.
Also, you'll use the sine rule.
Oh,
To find the area of that triangle.
okay. Let me redraw my triangle. I was saying my triangle will be like this. This is A, this is B, this is C. Then I said there is this. Okay. Then this is A, this is B, this is C. We want the area of this triangle.
So it will be half AC sine B.
So you are saying it will be the area will
Yes,
be
the area
half
AC
half A C. Okay, I can see A C there. Okay,
sine B times
sine
sine
B.
B.
You are saying sine B.
Yes.
Oh, almost there, but the formula is incomplete. Yeah, but thanks for the good approach, sir. So I can see now what you are trying to do here. So this is the formula for area rule. So this is the formula for area rule. I love this approach of yours, sir. Area rule. Or let me just erase this here. Dun, 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 dun. So yes, this is an area rule, but this is how area rule works. So area rule works like this. If there exists this triangle here, and then now let's say you are given this angle here, you are given this angle here, what you will do with area rule? Okay, area formula for area, I think it's always having that half there. But now with area rule, after that half, you're going to multiply. What are you going to multiply there? You multiply those sides that intersect at the given angle. So in this case, you're going to multiply AC times AB. So AC and AB are the ones that meet there at the given angle. Then now you multiply by the sine of that given angle there at A. I don't know if it makes sense now, sir.
Yes, sir, it does.
Are you sure?
Yes.
Okay, thank you. Does it make sense to everyone, guys?
So can you explain again?
Okay, okay. So what I'm saying, uh, with this area rule, okay, I'm saying you are given a triangle ABC. Okay, maybe they gave you the length AB, AC, BC, but they don't they won't give you one side. They will give you it either three sides or two sides, but there will also be an angle in the triangle. There will be an angle. So what you will have to note, you will have to note those sides that meet at the given angle. Those are the sides that you are going to use. So we have this side and that other side there. Those are the sides that you are going to use. So now an area is going to be half times the product of those sides that meet at the angle. So in this case, it's AC times AB. So it's going to be AC times AB. Then now, this is area rule. You multiply by sine angle that you are given, the one that we talked about. Does it now make sense?
Yes, sir.
Yes, sir.
Okay, I hear feedback from two people.
Yes.
Does it make sense to everyone, guys? Okay, I think it makes sense to everyone. So, okay, if you guys now understand how area rule works, we are fine. And then you again understand how this triangle works. If we have this, then now the area for this will be half base times height for this one. Then now for this one, again, we can have the situation whereby now we have this. This is A, B, C. And then now we are not given the angle. We are given A, B, and C. And then we are given the height. So this condition here is the same as the condition for here, because this triangle here have got the base A and the height H here. Therefore, the area for this triangle will also be half base times height. Does it make sense, guys?
Yes.
Oh, okay. Then if it makes sense, then let's quickly go to this explanation here. We have got this explanation here for these triangles with the same perpendicular height. We have this triangle, bigger triangle ABC here. Here. This is a triangle with the height H here. Okay. We also have this other triangle here. A, B, P. It also has the same height, H, but now the base is this one. Then for ABC, the base is this one. Okay. We also have another triangle here. This is a triangle APC. APC with the height, same height, H. Then its base is PC. So it's important to note the base and to note the height. Okay, now they did this example here that if maybe you are required to find the area of a triangle, room, boom, 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 boom. If you are required to find the triangle, the area of ABP over the area of ACP, then this is what you can do. You quickly go extract the triangle ABP. Oh, here is ABP. This is ABP with the base BP and the height H. Okay, therefore I can write the area for that triangle as half times our base. What is our base? It's BP all over, times the height H. Here is the height H. Okay, all on there. And then all over, now the triangle ACP. ACP is this one here. ACP. ACP. This is ACP here with the same height H. And then now its base is what? It's PC. It's PC. So the formula for this will still be half times base times height. So half times the base for this triangle is PC. So we substitute the base PC times the height H. Therefore, now this H will cancel out with this one. This half will go out with this one. We will be left with BP over PC. Just like that. Does it make sense, guys?
Yes, sir, it does.
Okay, it does make sense to Bongani. What about others, guys? Are you still there?
Yes, sir.
Does it make sense?
Yes, sir.
Okay, guys, thank you.
Yes,
Same
sir.
applies. Okay, thank you. Same applies with this one. The area of a triangle ABP all over the area of a triangle ABC. ABP, where is ABP? Is still this one. ABP, and then over ABC. Then the base of a triangle ABC will be this one. BC. Okay, and then now we substitute the base. The base for the triangle ABP will be BP. And then you substitute your BP. The base for the triangle ABC will be BC. And then you substitute it. This half goes out. I mean, this half and this half, this H and this H. You are left with your BP over BC. Same applies with this last condition. Now that the area of ACP with the base PC, okay, and then triangle ABC all over now half times the base BC. Same applies H and H, half and half. We'll be left with PC over BC, and then you are done. Now this simply tells us the ratio of the areas is equal to the ratio of the bases, just like that in simple terms. You don't necessarily need to go play around those halves and those heights. Just know that the ratio of the areas is equal to the ratio of the bases. Does it make sense, guys?
Yes, sir.
Yes, sir.
Okay. Okay. Thank you, guys. Then we can quickly go to the next type, type 2. Now for the common angle and the parallel lines. Common angle and parallel lines. Okay. Now we are here. Guys, can you just please listen? I think you are going to need this because you might find these questions in your paper 2 for September, for June, and for also in November. So here they are saying the area of a triangle APQ. APQ is this triangle here. Okay. And then now the area ABC. ABC is the bigger one now. The bigger one is the bigger one. So with this one, we can see that this triangle share that angle. That's when now we are going to use that area rule. So now the area of triangle APQ, that will be half times those sides that intersect at the angle of the focus. So these are the sides that we are talking about in the triangle APQ. Therefore, we'll say half times AP times AQ here times sine of the angle of the focus. Okay, all over. Let's go to triangle ABC now. It's going to be half times AB times AC times sine angle there, angle A. Therefore, now we have sine A, we have sine A, we have this half, we have this half. Now we are left with this AP over AB times AQ over AC. Does this make sense to you guys?
Yes, it does.
Okay, it makes sense to Gongani. What about others? Are you guys still confused or what's happening? Are you guys still following?
Yes, sir.
Yes, sir.
Right. Okay, thank you for the feedback. Now, we are saying we can see that if PQ and BC are parallel in this triangle, proportionality theorem applies now that you can say AP all over AB. AP over AB will be equal to the ratio AQ all over AC. Reason being proportionality theorem, then you state your parallel lines. or line parallel to one side of a triangle. Therefore, if this is equal to this, you can just say AP times AP all over AB times AB, which will just give us this. Or if you choose AQ over AC squared, you can just also go for it. Therefore, now this conclude by saying the ratio of the areas in this case is whereby there is a common angle and parallel lines. The ratio of the angles is equal to the ratio of the corresponding side. Then you square that ratio. Does this make sense, guys?
Yes.
Okay, thank you. Then, what's happening? Let's say, let's go to this example. So, okay, let's first read the statement. They are saying in the sketch alongside PQ is parallel to AC. PQ is parallel to AC. Okay, this is important. Proportionality somewhere might apply. PR is parallel to BC. Okay, and then we are given that, excuse me, BQ here is 4 over, oh, this is 3. Okay, and then now what are they requiring us? Is triangle ABQ. Where is ABQ? This is ABQ. This is ABQ. Okay, and then all over ACQ. That all over, oh, this is ACQ. That all over ACQ. This is ACQ. Okay, but these two triangles will have the same perpendicular height. Will have the same perpendicular height. Therefore, we said with that type 1, if triangles have same perpendicular height, we can say the ratio of the angle of the ratio of the areas is the ratio of the bases. So if a triangle, this triangle was the numerator, that triangle that is the numerator, the base of it will be numerator also with the ratio. So let's come to this one. I mean, what's happening here? So if we come to this one, the numerator is ABQ. So meaning if triangle ABQ, we are going to take the base of triangle ABQ, put it on the numerator. So the area for this ABQ, the base for that is BQ. So it's 4. Okay, all over ACQ, it's this one. The base for this one is 3. Then you are done just like that. Does it make sense, guys? Are you guys still there? Is there anyone who is lost? Are you guys still there?
Yes, we're still here, sir.
Do you guys understand what I've just explained?
Yes, sir.
Oh, okay. Thank you, guys. Then let's go to number B. Find the area of BPQ. Let me just fast. BPQ. BPQ is this one. BPQ is this one. Okay, that is BPQ. What's happening? And then ABQ. ABQ. Yes. Okay, this is ABQ. Okay, now how are we going to tackle this one? Anyone, guys, who can tell us how we can approach this question? Okay, without wasting any time, now we have got this triangle BPQ and ABQ. So this triangle, if we take this side, maybe this side as our floor, this side as our floor. Therefore, now our height will be right here, perpendicular to the floor. Perpendicular to the floor. This is the height of the two triangles. This is the height H. This is the height H. Okay. Oh, my apology, guys. The system just kicked me out, but I'm now back. Let me share back the screen. Can you all hear me now, guys?
Yes.
I don't know if you now guys can hear me because a lot has happened now. Can you guys hear me?
Yes, sir.
Yes,
Okay.
sir.
Thank you. I was doing this problem number B here in example 12. I was busy drawing these triangles, and then now the system just kicked me out. Continue. Oh. Then triangle BPQ. BPQ is this one, and then with this triangle, we have the other one, ABQ. ABQ is this one, ABQ. And then now I said to you, let this side AB be the floor of our triangles. So these triangles, they lie on top of this floor AB. And then now the height that will be perpendicular to that floor, and then note that the height is the maximum length that goes up of the triangles. So the maximum point is that one at Q. Then we go straight with the line that will meet that base perpendicularly. So like this, like this, like this. Okay, this will be 90 degrees right here. Okay, and then what do we now need to do? Okay, now the triangle BPQ, if this is the height for that, the base will be this one here. Okay, and then ABQ, if this is the height for that triangle, the base for that one will be this one. But now the question is, we don't have the length of this side, but we have the ratio for that. Since we have the ratio for BQ is 2 and QC is 3, therefore we can just use proportionality theorem. Now we can just say BQ over QC is equal to BQ is BP now, BP all over PA, that is proportionality theorem. And then you state your parallel lines there. And then now, okay, this prop theorem. And then you state your parallel lines that PR is parallel to BC. Okay, and then now we are saying BP is equal to BQ. This will be 2 here. Okay, and then BA is equal to B. Man, what did I do here? My bad. Not this whole side, but this one, PA here, not BA. PA here is equal to QC. Therefore, PA will be 3. Okay, and then now the area for this will be the base of this triangle BPQ. BPQ, the base for that is BP. BP all over ABQ is AB here. Okay, and then what is BP? BP, we said that is 2, and then AB is the whole of this, then it's 5. Then you get 2 over 5. Then you are done for the area of that ratio. Does it make sense, guys?
Yes.
Okay, I hear feedback. I can hear some feedback from only one person. What about others, guys?
Yes, sir.
Okay, thank you. And then now you will do the same with these others. So with the others, what you will just do, you will just go extract the triangle APR. Let's see now where the APR is. APR, oh, okay. APR is this triangle here. This is APR here over ABC. ABC is this one here. This is ABC. Any one of you guys who can tell us how we can calculate this ratio of these areas? Is there anyone with some idea, guys? Using those types that we talked about there. We have type 1 here. We have type 2. So anyone with an idea, guys? Anyone who wanna try? Are you guys still there? It seems like I'm left alone in the room here. Are you guys still with me? Or maybe my mic is off. Hey, hey, hey. Oh, it's on. Can you all guys hear me?
Yes.
Okay. Thank you. So, is there anyone, guys, who can give this question a try? Okay, guys. I believe maybe this question is a little bit challenging. Let me just. Dun, 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 dun. Bum, 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 bum. Bum, 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 bum. Bum. Let me just erase this. So for this one, we have triangle APR, which is this one here. Okay. And triangle ABC. Where is ABC here? Is ABC here. Okay. Then they share that angle A. Therefore, now we are not going to go for that formula of area that have got a height. So we are going to use that one for the area rule, whereby we are saying now the ratio of the areas is the ratio of the corresponding side squared. Therefore, for this one, we had AP over the whole side AB. Okay, now for this one, we're gonna say this is the same. Okay, AP, this is AP over AB. AB squared. Then what was AP? Okay, this was. What did I do? Where did I get those twos? While I have now 4 here, and then I have 3 here. Hey! But okay. Now we have 4 here. We have 3 there. We have 4 here. Okay, then AP is 4. It's 4 over AB. It's 7. Then all squared. Then that gives us 16 all over 49. Then you are done with the area of APR over ABC. Does it make sense, guys?
Yes, sir.
Okay. I hear some feedback from one person. Where are other people? Are you guys still following? Hello guys, are you still there? These guys are quiet. But okay. Then with same applies with D. You will play around your area, the types. You have type 1 and type 2. So let's proceed to the next part. Now, boom, 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 boom. So here we have got the triangles between the parallel lines. I think this is the last property. Oh, yes. And from there we are going to the exercises. So here now we have got the triangles between the parallel lines. They are saying triangles with the same base. This is important that these are triangles with the same base. And those triangles are between parallel lines, meaning they have the same height. So if triangles have the same height and the same base, it means that they have equal areas. Just like here, we have got the triangle ABC and triangle BDC, okay, with the same height BC. I mean, with the same height H and the same base BC. Therefore, the area for these two triangles will be equal. Now, if it is given that BC is equal to QR, and you have these parallel lines, these two areas will be equal to the area for that other triangle PQR, because these triangles have got the same base and the same height. Does this make sense, guys?
Yes.
Okay. Now we have got this example here, example 13. They're saying in the sketch alongside AE, AE is parallel to BD. Okay, and you are given that ratio ED for this part. ED is 5 and DC for here. DC is 12. Okay, now what can we maybe do? I don't know how to show that. Now again, okay, that's only the information that we are given. Now we are required to find the area of triangle ABD. ABD. ABD is this one here. ABD here. And then triangle BDC. Triangle BDC. BDC, let me change the color. BDC. This is BDC. This is BDC. So now we want the blue one over the red one. So what we are going to do for this triangle, we are going to use some complicated techniques, Nyana. So what we are going to do here, we can see that a triangle, let me say, area here, area of the triangle ABD, ABD is equal to the area of the triangle BED, bed, BED. This is BED. This is BED. This is BED. Why? Because these triangles, they share this base here, BD. They share this base, BD. So my reasoning, and they are between parallel lines, AE and BD. So I'm going to say my reasoning is same base, same base, and same height. Same base and the same height. Okay. And then now, what we can do, because you can see that this orange triangle and this red triangle, they share that common point B. Therefore, that can be our height for the two triangles. And then now the height for these triangles is going to be H. Therefore, we can say now, we said ABD is equal to, the area for ABD is equal to the area for BED. So this is what we're going to do. The area for BED is the half times base for BED, it's ED. So it's ED times the height all over BDC. BDC, the base for that is DC. DC times height. This cancel out, this cancel out. We are now left with ED all over DC. Then what is ED? It's 5 all over DC is 12. Then we are done because the area now of this is equal to that. Now this is still the area of the ratio for area of triangle ABD all over the area of triangle BDC. Then you are done just like this. Does that make sense, guys? Hello, guys. Do you all understand how we calculated the area of ABD over the area of BDC?
Yes,
Yes,
sir.
sir.
Are you sure? Are you guys
Yes,
sure?
sir.
Okay then, guys, thank you. I think we can end here for tonight so that next week when we meet, we are going to actually, I think I have to give you guys maybe a homework. This is going to be your homework, guys. I'm going to drop this homework there in the channel, so you guys please go and check it out there in the channel, and then we can discuss how you maybe guys approached it on the next lesson. Otherwise, thank you for being with me tonight, guys. I'm now logging out.